welcome back to my channel. Today I'm going to show you a new tutorial. I created this arc reactor clock. So I found this project originally from the internet, and I'm going to include the link in the description. But I tweaked it a little bit, and what I did is I replaced the screen with a round TFT display. This is called a GC9A01 round TFT display. It's 1.28 inches, and honestly it just made the project a lot more enjoyable to do. I also added a little bit more extras. There's going to be some buttons in there. I'm going to show you what all these buttons do. I'm also going to share my code, and I'm going to walk you through the code and tell you the areas that you need to update so that you could have a customized experience for yourself. So stay tuned. This is going to be an exciting tutorial, and I'll see you in a bit.
Okay, demo time. So we'll start off with the arc reactor turned off. You'll notice that I actually used a white filament as opposed to a clear one. It still works fine. The light gets diffused evenly. And this is the round display. It's called the GC9A01 TFT display. It's 1.28 inches. It's not touchscreen. Then at the back, I added 3 6mm buttons, and I'll show you what they do in a minute. And this is the power cords connects to the ESP32 Type-C. And so you could power this using any 5-volt input, like any USB port in your computer, or any 5 volts that will work. So you notice that when it turns on, it has this sequential lighting effect, which is great. And then once it's turned on, you'll see that there's a JPEG image behind it, and then there's a clock display, and then the LED ring. Now, regards to the buttons that I showed you before, so one of them is like the second button, which is at the center. What it does is it changes the position of the clock vertically. So now you're looking at it's at the bottom, but if you cycle through it, if you click and cycle through it, like this one is the clock is hidden, and then this one is the clock is the analog style clock. And then if you click it again, it will show the digital clock on top, and then if you click it again, the middle, and then goes back to the bottom. So that's what it does. Second button does. It cycles through the clock display. Now the first button is the background cycling button, and if you click it, it will go through the second, third, and fourth images that you've selected. You'll notice that the LED light color also changed, so you could set that will be the responsibility of the third button. And the nice thing about it, let's say for example I switch on to the new one, and this is the Spider-Man theme. And if I click on the third button, and if I decide to change it to, let's say, blue, it will remember this setting. Like the next time you go back and selected Spider-Man, it will remember to use the blue LED ring. So if you go to like a different theme, like I was able to set this for each one. If you don't change it, it will just take whatever is the current one. So let's say for example Deadpool, and if let's say you just want the image, you could pretty much do that, right? And then so I'll go through some examples. This one's really nice, Wolverine. And then the next one is the GIFs. Now these are These are very entertaining. I actually like this, and I set them on my desk, and it just makes me relax while I'm working. So you could, like this is the bug cat, and then this one is my favorite. It's just a cat walking. And got the matrix. And this one is one of those custom themes that I mentioned. It's the weather theme. And what this thing does is it shows you the current day, the current date, the current temperature, and you can see there's a very small texture called scattered clouds, and that just tells you a description of the weather. Feels like, you know, the high and the low, and then you got the icon in there to show you, like right now it's scattered clouds, just trying to show you some clouds, and so you also have the time. And then one thing that this thing does also is, depending on the temperature, this LED rings, they change colors. So let's say, for example, it turns to be like in the 90s, this LED ring will turn to red, and if it's like really cold, it's gonna turn to like icy blue. And then this one is the Pip-Boy. This is the Pip-Boy theme, and I really like this one. It has the Vault Boy GIF walking in there, and it shows you the time and the date. And you could see there's a Pip-Boy 3000 by Robco Industries. And then the last one is, this is the Apple Ring inspired theme, wherein you could see that the seconds updates, which is the red ring, it updates and it completes the circle, and it pretty much mimics how the Apple rings like behave. Like the moment that you're able to complete a cycle, it resets. It resets back, and then you could add different types of JPEGs and GIF files that you like, and then if you also thought of a theme that you wanted to add, just let me know and I'll try to accommodate that.
An assembly part, you could watch this video by Zeze Lenze. This is where I found the original project and tutorial. And as you can see, he's using a rectangular clock display. And what I did for my project is I upgraded that to use a TFT round display instead. So you could watch all of the this portion of the video for the 3D printing part and the hardware assembly, and then that's probably going to take you halfway of this whole video tutorial, and then after that you could switch on to my tutorial, and then you know, we could continue on. So let's say, for example, after you watch all that hardware assembly, we're gonna need to connect the TFT display to the ESP32 board. And so the diagram on the left side shows you that these are the pinouts. And so, for example, the TFT display has all these pinouts: the SDA, SCL, CS, DC, reset, ground, and VCC. So you could just follow the colors of the dots. For example, SDA on the TFT display will connect to the GPIO 23 of the ESP32 board, and SCL goes to GPIO 18, and so on. One note is for the VCC, make sure that you connect it to the 3.3 volts and not the 5 volt pinout of the ESP32. It might be able to take it, but I will not risk it. So just make sure you connect to the 3.3 volts. And then after you connected the TFT display to the ESP32, You could also go to this right diagram, and it will show you how to connect the LED ring to the ESP32. It only has 3 wires. The VCC, this one you connect to the 5 volts. The ground you connect to ground. And the data input you connect to GPIO 21. And that's about it for the LED ring. Now, I added 3 buttons in there for configuration to change either the cycle, the backgrounds, and that will be this background button. This is actually incorrect. You don't need to connect this to a 3.3 volts input, because I ended up using the ESP32's built-in pull-up resistors. So all you need to do for all of these 3 buttons is to connect the grounds together and connect them to common ground. And then for the other pin, for the signal, you could just connect this. For the background button, you can connect it to GPIO 22. For the position button, you connect it to GPIO 27. And the color button to GPIO 25. Now I chose this intentionally because they have the built-in pull-up resistors. If you decide to use a different GPIO pin, just make sure that they have the built-in pull-up resistors. Otherwise, you'll have to install an external resistor for this to work. Okay, so that's pretty much it for all of the hardware connections to the TFT display in the ESP32. Next, we could move on to the software part. So if you go to my repo, you could select Arc Reactor Clock, and you could just either fork this, clone this repo, or just download the zip. It should just work fine. And what you will see there are the STL files. These are files that you could download and 3D print. And then if you go to the main project, multi-mode Arc Reactor Clock, you'll find all of the header files and then the main sketch file. Now going to Arduino IDE, the first thing that you want to do is go to config.h and update it with the Wi-Fi credentials, the weather API key. So this is from openweathermap.org. You could get if you sign up, you could get a free API key. I recommend you just do it. It's very simple. You just go to their website, and after you've signed in, you could go to your API keys and just fetch it from there and copy and paste it. Now for the Weather City ID, what you could just Google this pretty much. If you say like Weather City ID of San Francisco or use ChatGPT, it will pretty much give you this number, and you could just copy and paste it. And then you could set the weather units to either imperial or metric. And then the last thing that you need to do is you just set the offset of the time zone that you're in. I'm in San Francisco, so pretty much that's PST. And you could also just Google that number for whichever time zone you are located. And so you're done with the config.h. After that, you could go to the main sketch file. And what you need to do is make sure that all of these dependencies are installed. And the way to do that is if you go to your library manager and then you search for the dependencies. Let's say, for example, TFT ESPI, which is the second from this includes. If you search it, it will just show up here. And if you haven't installed it, you'll have this install button. So if you try to click on verify with this check mark button on the top left and you get a compile error, it's most likely you're missing some of the dependencies. Okay, so once after you installed all of those, you need to do one more thing, and that is to modify the TFT ESP SPI library to enable the GC9801 driver. And so unfortunately, you can't modify this dependency libraries directly on the IDE. So what you need to do is go to the location of the library, which is in Documents, and then you're gonna have like Arduino libraries, and then you'll find it here and say we're looking for TFT ESPI, and we need to modify two files: user setup select and user setup. And the way you do that is just you open it on any text editor. So I have them open in Sublime. And if you go to user setup select, you need to scroll down until you find GC9801 ESP32 header. You need to uncomment this line, and then if there are anything other lines that are not commented, you comment them out, because you only need to enable one set of driver, and it's this one that you want. And then you could save this and close it. And then the next thing is you move to user setup. And then if you scroll up, you'll find the pinouts. Just make sure that you have this pinouts as I have them, you know, like Mossy's 23, clocks 18. If you decide to change the pinouts from how you connected the hardware, then you just need to modify this also. And then the last one that you need to do is if you scroll down to SPI frequency, I have it set to this value, so you might as well just copy what I have, uncomment this, and then comment anything else that's not commented in this area, and then you can save and close it. And then you can just go back to Arduino IDE and you click on the upload, and it should work. Well, not yet. You need one more step to do it. You need to upload the assets, which are the JPEG and GIF files. And I provided some JPEGs and GIFs in my repo. Go back there, and you'll see they're going to be under this data folder. I created this folder. You need to have this actually data folder, and then inside there I have this file naming convention, and the way you do this, like, you know, you're gonna see Iron Man first, Hulk second, etc. Now there are three special files here: Apple Rings, Volt Boy, and Weather.jpg. You need to keep these files. Everything else you could replace, but all these three files, you need them because they're used by our custom themes: the Apple Rings theme, the Pip-Boy theme, and the weather theme. So you need to keep this three, and then everything else you could change. Now, how do you upload them? So unfortunately, you cannot do that using Arduino IDE, like that is version 2 and above. You need to download an older version, and so that's what I did. I downloaded Arduino 1.8.19, and then in order for you to upload the files to your spiffs in the ESP32, you need to copy I included it in my project also. If you go to Arduino plugins, you have this file structure: tools, ESP32fs tool, and then ESP32fs.jar. You need to copy this whole directory, and then you go back to your Arduino, and then you paste it on that root folder. So you see this tools, ESP32 tool, ESP32fs.jar. And then once you do that, just restart the Arduino IDE. And then after that, you could go to tools, and you will see this option, ESP32 sketch data upload. Now, when you click this button, all of the files that are inside the data folder will get uploaded. And if you delete any of the files here, they will also get deleted from the ESP32 spiffs. So that's how you pretty much upload and download, upload and delete assets. Now, if we inspect one of these guys, you'll see that the size, the dimensions are 240 by 240. So what you need to do is if you find a JPEG that you like, you need to go and resize that to 240 by 240. And that's pretty self-explanatory to do. The same goes for the GIF files. Now the GIF files, you have a little bit more tweaking to do. Based on my testing, I found that, let's say for example, you go to any website and you download a GIF file. If you go to like analyze GIF, is a GIF analyzer, you'll find this, you'll find the size and the length. Now, what I found out is like anything that is below 110 kilobytes and less than 1 second in duration works. Anything like a deviation from those requirements is iffy. It's either it works or it doesn't work. Now, if it doesn't work, there are online tools like easygif.com wherein you could upload your GIF file and then you could resize it to whatever you want. Like I already, like this one is 270 by 270. You could reduce it to 240 by 240, and then you can also click on optimize, and you could increase the compression level, and that will try to get it down a little bit more. In this case, this is already good because it's 91. Anything beyond 240 just means like it's not going to show on the screen. It's just going to be a little bit further out. But since I already got it down to less than 108 kilobytes, I didn't care. But if it's still bigger than that, there are other tools like, for example, cut. You could cut it by frame or cut it by time. So let's say, for example, you want to do like 0 to 0.9, and then you cut the duration. The other way to do it is you could go to frames, and then you could try to skip some of the frames to reduce the file size. And then also you could change the delay. Like if you go to delay time here and you change this here, it will change it for all of the frames, and that way you could try to reduce it so that the total is less than 1 second, right? And after you do that, you just do the same exact thing. You upload it using the ESP data uploader, and then you just test it. And that's it for this tutorial. Let me know if you have any questions or if you have any suggestions or requests. And don't forget to hit that subscribe button for new content. Till next.